Good morning and welcome to the session 18 from the playlist of current electricity. The topic is the grouping of cells, and based on this topic I have written here three important points which will help us to understand this topic in brief. So the group of cells is called a battery, and the grouping of cells are done in order to get a battery of desired EMF. So there are basically two most commonly used ways of grouping the cells. The first one is the series grouping and the second one is the parallel grouping. So in the series grouping, a group of cells are joined together so as to supply the current in the same direction. So in order to understand this definition, I have made one simple diagram here in which there are three cells which are connected to each other in series with the same polarity. And here the cell number 1 has an EMF value of E1 and internal resistance of R1. The second cell has an EMF value of E2 and internal resistance of R2. And the third cell has an EMF value of E3 and an internal resistance of R3. So the equivalent EMF of this combination will be equal to E1 plus E2 plus E3. So this is the E equivalent is the equivalent EMF. So the equivalent EMF of this series combination in which the cells are connected to each other with the same polarity will be equal to E1 plus E2 plus E3, and the equivalent internal resistance, that is Req, this will be equal to R1 plus R2 plus R3 in this case. That is in the case in which there are three cells which are connected to each other in series with the same polarity and having the internal resistance and the EMF as shown in this figure. However, if there are n cells, then the equivalent EMF, that is Eq, will be equal to E1 plus E2 plus E3 and so on up to En. And the equivalent internal resistance, that is Req, will be equal to R1 plus R2 plus R3 and so on up to Rn. Now, if one or more cells are joined together with opposite polarity, then the EMF of those cells will be taken as negative. So in order to understand this definition, I have drawn here one simple diagram in which there are four cells of EMF value E1, E2, E3 and E4 having an internal resistance, say R1. The second cell has an internal resistance of R2. The third cell has an internal resistance of R3. And the fourth cell has got an internal resistance of, say, R4. So here in this diagram, you can see that the third cell, that is the cell with an EMF value of E3, is connected with opposite polarity. So in this case, the equivalent EMF of this grouping of cells, that is E equivalent, will be equal to E1 plus E2. And since this third cell having an EMF value of E3 is connected with opposite polarity, so its EMF value will be taken as negative. So the equivalent EMF of this combination will be equal to E1 plus E2 minus E3 plus E4. Now let's come to the last point, that is the parallel grouping of cells. So in the case of the parallel grouping of cells, the equivalent resistance is given by this formula, that is 1 upon R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus and so on up to 1 upon Rn, where n is the number of cells which are connected to each other in parallel and Req is the equivalent internal resistance of that parallel combination. So here I have connected three cells in parallel, and in the parallel combination the positive terminals of all the cells are connected together as shown in this figure, and the negative terminal of all the cells are connected to each other as shown in this figure. So here you can see that the positive terminals of these three cells are connected together, and the negative terminals of these three cells are connected together. So this is the parallel combination. So in the parallel combination, the most important thing which you all have to remember is that the positive terminals of all the cells are connected together and the negative terminals of all the cells are connected together. So in this case, this equivalent EMF and the equivalent internal resistance. So in this case, the equivalent internal resistance will be given by this formula, that is 1 upon R equivalent, where R equivalent is the equivalent internal resistance of this parallel grouping of cells, which is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. And if there are n cells, then this is the formula, that is 1 upon R equivalent will be equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on up to 1 by Rn, where R equivalent is, Req is the equivalent internal resistance of that parallel grouping of cells. And for n cells which are connected to each other in parallel, then the equivalent EMF will be equal to R equivalent multiplied by in bracket E1 upon R1 plus E2 upon R2 plus E3 upon R3 and so on up to En upon Rn. So this is the formula for n cells which are connected to each other in parallel. However, in this case, the equivalent EMF will be equal to, that is EQ. This is the equivalent EMF of this parallel grouping of cells. This will be equal to Req, where Req is the equivalent internal resistance of this parallel grouping of cells multiplied by E1 upon R1 plus E2 upon R2 plus E3 upon R3. So this is the equivalent EMF of this parallel grouping of cells. And the general formula for the equivalent EMF is given by this, that is EQ is equal to Req, where Req is the equivalent internal resistance of that parallel grouping of cells, and EQ is the equivalent EMF of that parallel grouping of cells. And so EQ is equal to Req multiplied by E1 upon R1 plus E2 upon R2 plus E3 upon R3 and so on up to En upon Rn. And the equivalent internal resistance of n cells which are connected in parallel to each other is given by this formula, that is 1 upon Req, where Req is the internal, this is the equivalent internal resistance of that parallel grouping of cells, and this is equal to, so this is the formula, that is 1 upon Req is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on up to 1 by Rn. And here Req is the equivalent internal resistance of that parallel grouping of cells. So thank you very much for joining this session. In the next session, I will be coming up with a question which will be based on this topic, that is grouping of cells. So till then, have a nice day. Bye.